This is a quick video on how to do logistic regression for proportion data in Excel using the method of maximum likelihood estimation. We're going to use a data set here that's based on 446 teens aged from 14 to 18, and it shows how many hours of sleep they got at night. They responded either that they got 7 hours of sleep or more, yes or no, and that data is broken down here. To do the logistic regression, we're going to use 5 steps. First, we'll calculate the logit for each data record, and those will be as a function of 2 coefficients, B0 and B1. Those coefficients are over here. We're going to solve for those later. Right now we're using an initial guess of 0.1 for each. Next, we'll calculate e to the L, the logit for each data record. Next, in step 3, we'll calculate the probability for each data record, and the probability formula is given here. E to the L over 1 plus e to the L. Next, we'll calculate the log likelihood. That formula is given here. If you look at that closely, you'll recognize that as the binomial distribution formula after you've taken the log and discarded the combinatorial constant term. Finally, after calculating all of those, we will maximize the sum of the log likelihoods using the solver built into Excel. So to do this, we've repeated the data down below. We've added the total column, which is just the sum of the yes and no values, and we've added the proportion column, which gives the proportion of yes answers compared to the total for that age group. Then we go through and we do step 1, which is to calculate the logit as a function of B0, B01, and B2. And then step 2, we calculate e to the logit. Step 3, calculate the probability. 4, calculate the log likelihood. And then 5, calculate the sum of the log likelihoods, which is the sum of this column. This is the field that we're going to try and maximize using the solver. To do that, we use the solver built into Excel. And we are going to use the sum field as the objective, and these two, the B0 and B1s, as the variables that we're going to change. We'll make sure that the make unconstrained variables non-negative option is turned off, and we'll use the standard GRG nonlinear solver. Click on Solve. Excel found an answer for us. We'll click on OK, and it updates and stores those results here. The next thing we're going to want to do is to use those fitted coefficients that we just calculated to do an estimation based on the logistic regression curve for a new age value. So in this case, we want to calculate the value, the probability for the age 16 and a half. And that's shown as an example down below. What we're doing is repeating steps 1, 2, and 3. We're recalculating the logit, e to the L, and from that we can calculate the probability or proportion of that 16 and a half value. That comes out to be shown down below here. One final thing we might want to do is to take another tool, like R in this case, and use it to verify that the results that we calculated match what R would calculate. And that's done and shown using a separate sheet within this spreadsheet. It's in the R code sheet. Within that, there's sample R code that does the analysis, the same analysis that we did before, both the logistic regression and the prediction. And the output from that analysis is shown here, and you can see that the results calculated by R come out exactly the same. Same thing for the prediction. It also shows a plot to show how the logistic regression curve fits the initial 5 groups, age groups that we had. So hopefully that helps. The spreadsheet is on a link down below. Give it a try.